When most of us picture a nuclear explosion, we think of that single blinding flash and the iconic mushroom cloud. But really, that's just the start. It's not one single event. It's more like a cascade, a series of devastating ripples that spread out, not just in miles, but in time. So today, we're going to break that down, second by second and mile by mile.
All right, let's dive right in. The energy from a nuclear weapon isn't just one big thing. It gets split up into four main types. As you can see here, a whopping 50% of the energy fuels the blast wave. That's the raw, physical force. Another 10% becomes that lingering, dangerous fallout. And 5% is something called initial or prompt radiation. But we're going to start with that big 35% slice, thermal radiation. And why there? Well, because it's the very first thing to arrive, traveling at the speed of light.
So this first ripple hits you before you can even blink. It's this incredibly intense pulse of energy that you'd see as a brilliant, totally silent flash. This is that thermal radiation we were just talking about, a wave of pure heat, moving way, way faster than the speed of sound. And to be clear, this is so much more than just a bright light. It's a massive, massive wave of thermal energy. On a clear day, it's powerful enough to cause third-degree burns and start fires for miles and miles from ground zero, way beyond where the actual blast itself even reaches. And this is where it gets really chilling. That flash happens so fast, so unbelievably fast, that any solid object, a wall, a railing, even a person, can cast a sort of protective shadow behind it. In Hiroshima, these nuclear shadows were all that was left in some spots, a permanent, haunting record of just how intense that heat really was. Okay, so just fractions of a second after that silent flash of heat, the next ripple arrives. This is the blast wave. This is the primary destructive force, the thing that is responsible for leveling entire cities. So how do you even measure this kind of force? Well, we use something called pounds per square inch, or PSI, of overpressure. That's pressure above normal. And you might hear 5 PSI and think, well, that doesn't sound like a lot, right? But at just 5 PSI, most regular city buildings are going to suffer major damage. We're talking walls cracking, windows completely blown out, and roofs just torn away. Now, bump that up just a little bit to 8 PSI, and you hit a level of almost total destruction for typical homes. When they did the surveys in Japan after the war, this was the pressure that just flattened entire neighborhoods of wooden and brick houses. But here's what's really crucial to get. The damage doesn't just come from one single push. It's this devastating 1-2 punch. First, the shock front hits. It's like a wall of air that crushes buildings inward. And then right behind it come these insane winds. We're talking over 600 miles per hour that just rip apart the structures that were just weakened. Beyond the destruction you can see, the fires and the collapsed buildings, a nuclear detonation launches another kind of assault. This one is completely invisible. It's silent, and it targets both our technology and our biology. Okay, so if a weapon goes off way, way up in the atmosphere, it creates this massive electromagnetic pulse, an EMP. And it's not just one thing, it actually comes in 3 different ways. The first one, E1, is this super fast spike that fries delicate electronics. E2 is a bit slower, kind of like lightning, and it can get past some protected systems. And then there's E3, a very slow pulse that can actually overload entire power grids. Now, what's so fascinating here is how our own technology has actually made us more vulnerable. It's wild, right? The old clunky vacuum tube electronics from back in the day, they were pretty tough against an EMP. But our modern solid-state microelectronics, all those tiny, delicate circuits in our phones and computers, are literally thousands of times more fragile. At the exact same time all this is happening, there's another invisible ripple. It's a burst of what we call prompt radiation. Think of these neutrons and gamma rays as microscopic bullets that literally shred your DNA and your cells. The effect is definitely most intense near the explosion, but it's a huge part of that immediate lethal danger. But the assault on human health doesn't just stop after a few seconds. Oh no. The next ripple, radioactive fallout, doesn't just cause a crisis. It creates a medical catastrophe that can last for generations. I mean, just look at this number. Let it sink in for a second. Over 2.5 million. Since the 1950s, that's how many outpatient visits the Japanese Red Cross hospitals have had just for atomic bomb survivors. We are decades out, and these hospitals are still treating thousands of survivors every single year. And when you look at the data from those hospitals, it just paints a heartbreaking picture. For the survivors who passed away in the Hiroshima hospital, nearly 2/3 of the deaths were because of cancer. And you can see here, certain types like lung, stomach, and liver cancer are tragically common, showing up decades after that initial exposure. This heartbreaking reality leads to an even bigger and, frankly, deeply disturbing question. Could the genetic damage from all that radiation actually be passed down to the children of the survivors? Right now, as we speak, there are huge studies following this second generation, the children of the survivors. This group of about 200,000 people is just now getting to the age where cancer risks normally start to go up, and scientists around the world are watching, trying to answer that terrifying question: will the poison of 1945 claim victims in a whole new generation? So we've seen the ripples spread from an instant flash to a decades-long health crisis. We've gone from the city to the individual. But there's one last ripple. And this one goes global. It has the potential to engulf the entire planet. And here's the part that is really shocking. It wouldn't take a full-blown war between superpowers. Climate scientists now figured that even a regional conflict, one that uses as few as 100 relatively small nuclear weapons, would be enough to trigger a global climate disaster. So what happens? Well, the explosions from a war like that would throw millions of tons of soot and smoke high up into the stratosphere. That soot would block sunlight, causing temperatures around the world to plummet and absolutely crippling agriculture. The result, a nuclear famine that could put the lives of up to 2 billion people at risk. And look, this quote from the International Physicians for the Prevention of Nuclear War really says it all. Even a so-called limited nuclear war would be a global catastrophe, threatening billions with starvation, people who are thousands of miles away from any blast zone. That final ripple, it touches everyone. So when we think about a nuclear weapon, we can't just see the mushroom cloud anymore. We have to see all the ripples that follow. The wave of heat, the crushing blast, the invisible electronic attack, the decades of cancer, and the shadow of global famine. It's an explosion that's over in seconds, but with consequences that may never, ever truly disappear.